Homework Hotline, what is your emergency?
Hi, it's Pie Day here at the Homework Hotline.
Dessert pie, savory pie, pizza pie?
Now I'm hungry. Unfortunately, it's actually just Mathematical Pie Day, which is, I shouldn't say just, it's actually pretty great too. Fortunately, although I am hungry, because today is actually March 14th, or 3/14.
So we'll of course take questions on science, English, and math like normal. However, if you want to call in something about pie, please do.
So we're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. and we love it when Pie Day actually falls on our Homework Hotline filming day. Call us at 720-424-1666, number's right up there. And as Sam said, you can talk to us about pie today, or you can call with a regular question. When you call in, we can help you in more depth. You can watch us while we answer your question. So Nate, how can our viewers watch?
Well, they can watch in several different ways. For live broadcasts, you can tune in to Comcast Channel 22, or this is very exciting for us, you can watch on our new high-definition channel, Comcast 882. And there's also Prism TV, channel 8007, or you can go to livestream.com, click on Discover, and put in DPS TV. We also take advantage of Facebook Live, so you can find us at EG Homework. If you would like to see some of our past shows, you can watch us on YouTube by searching for Denver DPS TV.
Yeah, and the show is sponsored by our two high schools. I teach at the Contemporary Learning Academy, and Becca and Nathan teach over at Emily Griffith High School. So in a twist today, Becca and Nathan will be performing an easy as math demo.
Easy as something.
Easy as something.
Easy as something. I've got that written here. I'm not sure what that means.
Figure that out. Okay. Think about the missing words, Sam.
Oh, sure. Sure.
You'll have to catch that in about half an hour.
So we'll also take your social media questions from our social media master. Michael, why don't you tell us a little bit about yourself?
Hi, I'm Michael. I'm a DPS TV intern. The Homework Hotline wants to be as accommodating to all of you who love social media as much as I do. So I'll be checking all your questions via email as well as Twitter and Facebook, so go ahead and use those as best as possible. And we can answer any question on the subjects we have available for you guys today. I'm also the trivia master, and I will ask a trivia question at the top of the show. We'll revisit it later in the show as well, and then if we get an answer, we have a nice little prize for you guys today. Can you guess what the topic of our trivia question is today?
Is it pie?
Guessing it's pie.
I'll just ask the question for you guys today. What famous theoretical physicist was born on Pi Day?
That's serendipity of the universe.
Interesting.
That is very interesting. All right. Well, if you do have an answer for that, give us a call today before the show's over at 5:30, or you could also send your answer in to us on social media. Let's give you all of that contact information so that you have it and you can get us to help you with your homework. You can send your questions to us at Facebook or Twitter at EG Homework. You can send them via text message at 970-680-3771, or you can send them via email to us at homework@emilygriffith.edu. So you've got options and all the ways to get a hold of us. Just contact us and we'll help you with your homework. So let's go back to Michael and see what questions that we have that you've sent in that are waiting to be answered.
All right. Well, in honor of Pi Day, I figure we start with Pi question.
Oh, perfect.
Pi is an irrational number. What does that mean?
Becca, I think you always had a good explanation. All I can think of is that you can write it as a ratio or a fraction, but I know you had a good explanation for that before.
Okay. I usually go to my screen. I didn't even know. I don't need my screen, I guess, for this one. So a rational number, maybe I do want my screen. Hang on one second here. I do, because I want to break down that word there. So there are two types of numbers. You've got rational numbers, you've got irrational numbers. And rational numbers, as Nathan mentioned, rational, and as soon as my stuff comes up here, we'll do it. It's a little bit slow today. But a rational number, ratio, is in that word. And the word ratio means fraction. Here, I'm almost up here. I totally rely on this so much. All right, I'm up now. All right, here we go. So rational number has this word ratio in it, which means it's any number that can be written as a ratio, meaning a fraction. So it doesn't mean that it has to be written as a fraction, but it can be written as a fraction. Decimals count as ratios because if you think about a decimal, let's say I had something like that, that's the same as 2/10. That is a fraction. Or sorry, 2/100, my bad. That's a fraction. So decimals are also rational, but they have to be terminating, meaning ending. So they can't go on forever.
What about repeating numbers, though?
Repeating numbers, well, repeating number, here's an example of one. So let's say I had, well, that's not a very good one. Let's say I did 0.7 repeating. That actually can be written as a fraction.
Right.
So that would be the same fraction as 7/9. So a repeating is okay, that's rational, but it has to be non-repeating to be irrational. So repeating, yep, that can be written as a fraction, so therefore it's rational. Irrational, I guess the definition of irrational officially would be it's non-terminating, so that means that it's a decimal that goes on forever and ever and ever. And then it's also non-repeating. So it doesn't have sequences of numbers that repeat themselves. Like for example, 0.7777, that has sequence that repeat themselves. Another example of this repeating would also mean, let's say I had 0.676767. That has a series of numbers that are repeating themselves. So even though the 6 isn't repeating the whole time, the 7 is repeating. So that is also a rational number. So it is rational, back to that definition here, is non-terminating and non-repeating decimal. A lot of times square roots are irrational numbers. If you're wondering for an example, like if I did the square root of 2, you type that in your calculator, it's going to be a number, it goes on forever, and it doesn't ever repeat the sequence of decimals. So,
do you know the trick for writing repeating decimals as a fraction? I just learned that the other day and thought it was pretty cool.
It's over 9, over 9s.
So 9, the number of
So if I
nines
said,
based
like,
on like how many digits are.
0.67 repeating, it would be 67 over 99.
Yeah.
Right.
I literally just learned that. I had no idea how to do that.
Yeah, I didn't
cool.
learn it in school. I learned it
Yeah.
actually when I was tutoring math. But yeah, repeating decimals are always over 9s. It's kind of interesting.
Yeah.
Yeah. All right, I don't know, did I miss anything there?
No, I think you covered all of it.
Cool. Let's answer more of your questions. Michael, what do we have?
All right. I'm going to test you, Sam. I got an English question for you.
Bring it on. Come
What
on.
is the difference between active and passive voice?
Okay, so active and passive voice are, so I guess what I would say is this. Active is sort of the normal way that we speak. We typically speak in active voice. We typically write in active voice. Passive voice is useful in some contexts, and passive voice can even kind of give a sense of sounding a little bit superior in certain contexts. But typically, especially in like the academic context, unless you're doing science writing, there's a reason why you might want to do it in science writing, but a lot of times an English teacher might actually try to get you to turn any sentences you write in passive voice back into active voice, because active voice tends to be more clear. Let me explain exactly what I'm talking about. If we could jump to my screen really quickly, I'm just going to type up some of this stuff, and I think, make this bigger for us so we can maybe see it just a little bit better on your guys' screen. Okay, so active or passive. So the first thing that I'll start with is just that English is a subject-verb-object language. So we tend to organize our sentences with the subject coming first, then the verb, and then the object of the sentence. And if you're confused about what any of these parts are, I'll go over them a little bit as I go through a couple examples. But there are other languages out there that do not use this system. There are languages out there that are verb-subject-object systems. There are verb-object-subject systems. You can mix it up any which way, and it's one thing that linguists do is they can actually study different languages based on how they order the parts of their sentence, like subjects, objects, and verbs. So again, like I said, English is normally, I've got written here, subject, verb, object, SVO language, and that's how we're going to write passive voice. So like we might take a sentence like, and I'll highlight this sentence that I'm going to write here. Oh, not make it in yellow because that would be bad, but I'll highlight it in yellow so you can see what I'm doing. Okay, so I could take a sentence like, let's just take something really simple, like I could say John runs. So John runs just has a subject and a verb. There's no object there. For an object, we need what's called a transitive verb. We need a verb that can transfer the action of the subject onto an object. So let's keep John, I guess, super generic guy name. I should maybe come up with a better, weird, okay. I was thinking of like a unique name, but Becka works, it's better than John. Oh, sorry, Becka, jeez. Those CC Beckas are the worst anyways, so. Okay, anyways, so we'll say Becka eats, and then why would we not do this? Eats pie, right? So, because it just makes sense for today, right? So this is active voice, Becka eats pie, and to show you why that's active voice, I kind of have to show you what passive voice is, but essentially active voice can be thought of as the simplest way to construct a sentence in English. So then if we wanted to construct a passive voice, what we're gonna do is we're gonna flip the object and the subject, okay? So the object has to come first. And the way that we do this is we end up using the verb to be. And we also use the word by along with it. So let's see, so in this case, we're gonna say the pie, and then I wanna say that Becka ate the pie, but I have to say it in a backwards way. So I'm gonna say it was eaten by Becka. The pie was eaten by Becka. So this is the difference between active and passive voice. Passive voice uses, again, the verb to be is right here. I'm going to highlight the verb was, because that's a form. I'll just highlight in there. That's the form of to be that is used in this case. But this is all we're doing when we're using passive voice. And I just sort of want to get back to like, why would we use this, right? So if it was totally out of context and we just wanted to explain, and maybe what I'll do here is say, eats the pie. Like, we would probably want to stay with active voice, but there might be a reason, like the pie was eaten by Becka, might be a response to a question. Like somebody might say, who ate the pie? Where did all the pie go? And at that point, the pie is sort of the center of our focus and our interest. So now it makes sense in my response for me to start my sentence with the pie, because that's what we're focusing on. So if somebody said, where did the pie go, or who ate the pie, I would say, well, the pie was eaten by Becka, or that might be a response that I would make. And I guess here, you know what would make more sense here? Since we don't know where the pie went, we would maybe say here, Becka ate the pie. So let me also just clarify that if we used a past tense verb, like Becka ate the pie, like she ate it in the past, this is still active voice. Still active voice because we've got that standard sentence order, subject, verb, object, right? But it can have happened in the past. Active voice is more clear. You'll notice it takes fewer words. But again, there are maybe some circumstances where, for context, we're going to want to use, throw the object in front and put an emphasis on that. And then I'll just also throw out there that there are a lot of cases in scientific writing where passive voice is totally acceptable, maybe again because there's a reason to focus on the object of the verb. And at some point here, as I continue to get more English questions, and this is actually the first English question I've done on the show, so exciting. But maybe I'll get some questions around the idea of what a subject, what a verb, what an object is, and we can go into that in a little more depth at some point then.
I would say the advantage of it is to, if you're writing a 22-page senior thesis paper, to use passive voice a little bit to help that word count a little bit.
So I totally hear you, but I'm gonna push back on you, because if you do that, there is a chance you will get a professor that will look at it and go, I'm not going to read this until you take out all of the extraneous passive voice.
Oh, I did. I was totally kidding.
And yeah, so I mean, that's where it can sort of backfire on you. And you sound a little bit more educated, I think, when you use the passive voice. In some contexts, you can sound more educated. So I think that's, people tend to use it in academic papers.
Right.
But you want to be careful, because a lot of professors prefer, no, just tell me what happened. Did Becka eat the pie or not? Yeah, Becka ate the pie.
Yeah, I did get a little pushback in college.
Yeah, that's normal.
Yeah. Well, Sam, I didn't know that you could do the English. That's
pretty cool.
I
also have my English teaching license. So.
Oh, multi-talented.
Yeah, I lucked out. I never was really taught English grammar, but I learned Spanish when I was younger, and that was my original major in college. And learning another language really helped me understand English grammar. If you want to learn English grammar, I cannot recommend anything more than just learn a different language besides English.
Is that because you're like relearning the structure that we all kind of take for granted?
Exactly. It's like I know how to speak English. I don't have to think about speaking English, right? So it's almost, and I see why students get frustrated. You're in class, you're like, I know how to speak and write. You don't have to tell me all these little tiny things that don't seem to matter to me.
Right.
But when you're learning Spanish or another language, all of a sudden these things start to become important, and making those parallel connections in your brain of, oh, we do it like this in Spanish, we do it like this in English, and I see why now because I can name the parts of the sentence. Suddenly it was really relevant to me, and so I picked it up that way. So,
Makes sense.
anyways, learn another language. It's awesome.
So cool.
Yeah.
Multi-talent. All right, well, let's go get more of your questions answered. So what do we have, Michael?
We're going to avoid a pie question on this one.
Aw.
I'm going to give this one here.
Looks like pie, though.
Looks like pie.
Yeah,
Looks like a
kinda
delicious
does.
piece of
Slice
pie.
Yeah, pizza.
Can you help me solve for x? So you have a triangle with one angle at 3x, one angle at 4x plus 10, and one angle at 4x plus 5.
I had a student that looked at a problem like that the other day, and she was like, it's impossible because there's x in all the angles.
Yeah.
True, we're done.
There's
Impossible.
no way to do it. Yeah. No solution.
This kind of goes back to, I like that you said that was impossible, right? Because we do have 3 variables, but they're all the same. Well, we don't have 3 variables. We have
Well,
one
3
variable.
angles with.
3 angles, all with variables in them. And this would be impossible if we didn't have any sort of relationship. If literally all I was saying was, this angle is 3x, like, what does that mean? But because it's in a triangle, we do have a relationship. And that relationship is that all angles in, and I'm using kind of our geometry notation in a triangle, add up to 180 degrees. And this doesn't matter what the triangle looks like. It could be obtuse, it could be a right triangle, any triangle. All of the angles inside always add up to 180 degrees. So like we were saying, if I didn't have this relationship, yeah, this would be impossible. But we have some way to relate all of these angles. So let me give you a quick example. If I had a triangle like this, if this measurement of this angle were, say, 60 degrees, and this angle were 70 degrees, this angle would have to be 50 degrees. Otherwise, you can play around with it with a protractor, but if you try to create a triangle that doesn't match that, it won't form a triangle. If it's too small, they won't match up. But you could play around with it, but it will literally, unless they add up to 180, or you could just draw a bunch of triangles and measure them. So all we need to do here is say, look, you can think of these numbers and say 50 plus 60 plus 70 is 180. And I like to do these examples just to kind of show, I don't know, sometimes with the algebraic expressions, it can get a little confusing. So if you think about it with numbers and then apply the same to these variables, it makes a little bit more sense. So literally all we're saying is this angle, 3x, plus this angle, which we're referring to as 4x plus 10, that's some relationship with x, plus this angle, we're saying, and I'm going to put these in parentheses, it's obvious that they're separate, plus 4x plus 5 has to add up to 180 degrees. So this is a relationship we have, and now that you see this, you're probably thinking, oh, it's just an algebra equation. So all we're going to do, and I'm just going to remove all the parentheses, but you can kind of see, this angle, I literally just copied it from here. That's the relationship. And this angle is here, and the 3x is here. So from here, if I just rewrite this without the parentheses, I get 3x plus 4x plus 10 plus 4x plus 5 equals 180. From here, it's just a kind of multi-step equation where you need to combine like terms first, and then go through your normal steps of solving. So I go and I say 3x, 4x, and 4x. These are all like terms because they have that x variable attached. So I get 7x plus 4x, which is 11x. And then I go here and I say 10 plus 5. I'm going to get plus 15 equals 180. And I just solve this algebraically, subtracting 15 from both sides. 11x equals 165. divide by 11, and x should equal 15. So one thing you want to be careful of is this problem specifically said find the value of x. So if it says that, you're done. But if the problem asks you to find the angles, well, x is not the measurement of the angle. It's just that variable that relates all of these angles in the triangle. So again, this problem said solve for x, so you're good. But if I wanted to actually figure out what this angle is right here, then I would say that this is 3x, and I know that x is 15 now, so this is 3 times 15, which is 45. All right, so we're just plugging everything in here, and I could say that this is 4 times 15 plus 10, which is 70. And you can either plug in here, or you can say, look, I got 115 here. This has to be 65. You can double check it. 4 times 15 plus 5 is 65. So not impossible. It is impossible if you have one variable and you have no relationship or nothing to set it equal to. But in this case, in geometry, you have to think about all the relationships that you learn between angles, sides, and things like that to create an equation that's solvable.
Yeah, we talk a lot about if you can create hang on.
You got it.
Wow.
Tongue twister.
If you can create an equation, then you can solve it, then you can figure it out.
Right.
So it's all about coming up with some relationship and creating that equation. So,
Yep.
All right. I think we've got time for another question. What do you think, Michael?
I think we do as well.
Awesome.
And we're going to take it back to pie, but this time we're going to go to Sam.
Oh, cool.
Can you explain the process of fermentation? I know some fruits get broken down in this order to make pies.
Okay.
So I didn't know that. I didn't know that fermentation was used at all in pie making. My understanding was that pie making largely you're like sweetening fruit by adding sugar to it and kind of cooking it down into something that sort of like resembles like a not all the way cooked down jam. But the truth is I don't know that much about pies. But I do know a lot about fermentation. So I'll talk to you a little bit about that. So fermentation is the process of yeasts, and to a degree bacteria, breaking down sugars, and we typically are talking about fermentation as it relates to human food consumption. Human beings have been fermenting food going back probably probably longer than we've had civilization. So current estimates put the origins of civilization at like somewhere between 10 and 13,000 years ago, right? And so that's the time when anthropologists believe that early humans or early civilized humans, I guess I should say, began to develop agriculture in a way that was sustainable and that could sustain larger societies. And so if you've got a situation where you've got regular access to some kind of plant-based food, so specifically things that are going to have sugar in them like grains or fruits, and you have access to that regularly, one of the things that will happen is, and one of the things that did happen to early civilizations was they realized that they could create an abundance of food, but then that food would go to waste. And so fermentation is a process that increases the shelf life of food. It also changes the taste of food. And again, it's thanks to organisms like yeast and bacteria that these things are able to happen. So if we can come up to my screen, I'll just go through a couple examples and then I'll kind of get back to the fruit example. So this is sort of just a artist rendering of lactobacillus bacteria. So a really common type of fermentation that we talk about is the fermentation done by lactobacillus. So like yogurt that we eat. Yogurt it can be fermented by different bacteria and yeasts, but the most common one that we think of is lactobacillus. And lactobacillus is present all over the place. Surely there's lots of lactobacillus even in this room right now. And lactobacillus will get itself onto all different kinds of sugars that are in the environment. If you leave fruit out for long enough, lactobacillus in the environment can jump on there and start to get to it. But again, what will happen here is, so like lactobacillus, we call lactobacillus, you can probably hear that word lacto in it. Lacto refers to milk. The bacillus portion of the word refers to the shape of the bacteria, the fact that they're rod-shaped. It was known early on that you could take milk from a cow and you could leave it out under certain conditions, and the milk would convert to yogurt. And that has to do with the bacteria that were in there, and there are sugars actually inside of milk. There's a milk sugar called lactose, which is made up of two smaller monosaccharides called galactose and glucose. And the lactobacillus can chew down on these sugars and break them up and sort of pre-digest them and create as a byproduct of this pre-digestion lactic acid. And the lactic acid is what gives yogurt its sort of tart sourness and also makes it easier on folks who are lactose intolerant. So like a lactose intolerant person can often eat yogurt that's been pre-digested by bacteria or fermented by bacteria because milk sugar, lactose, which is one of the things that bothers folks that have lactose intolerance, is often broken down in yogurt. So when we think about yeast is, and I was going to show this picture too. Oh God, that's so blown up. Let me just zoom out a little bit. So this is just an image of grapes, and I'm sure everybody has seen fruit like this, and we sort of take it for granted, like fruit just looks like this, but almost everyone out there has probably noticed that a lot of fruit you buy has kind of this like filmy white stuff on the outside of it, right? Especially berries, grapes, right? So that white residue that you see on the outside here, and you can see, I'm just going to use my cursor, you can see here it's kind of rubbed away, right? So the grape itself doesn't have this. Grapes are just these purple orbs, but the white stuff around the outside are dead yeast cells because there are yeast literally living on top of the grapes. And so we think about wine fermentation, the production of wine in the past. This was literally just people taking grapes from the field, crushing them up, and then they knew that if they left them under certain conditions, again, mainly temperature and kept them cellared, the yeast that were already present, I mean, the folks didn't know that it was yeast at the time, but of course the yeast that were already present on the grapes would do the fermenting. And I'll just jump back to this. This is just a diagram of yeast and just sort of shows that very simply what yeast do is they consume sugar, they ferment the sugar, and they produce alcohol as a byproduct of that fermentation. And so this is the way that we make things like beer and wine. Like today, if you want to go out and make beer and wine, you get your grape juice or your grain juice, and you can go buy yeast in the store and pitch it into the juice, and that'll help turn it into the alcoholic beverage. But in the past, it was just natural yeast and bacteria living in the environment that allowed people to ferment these different foods. So just getting back briefly to the pie question, again, I wasn't aware that pie was a food that you used fermented fruits in, but it is easy and really cool to ferment fruits. You can, just in sort of a solution of water, you can leave fruits or even crush fruits up, and fruit juice left to the environment will naturally bubble and sour. So if you wanted to try this at home and ferment a little bit of fruit, you could. Now the only issues that I would say, the things that you would maybe want to watch for would be if you leave it for too long, you can have mold growth on top. So if you have any kind of growths on top of the fermented fruit, you would not want to consume it. That would be a batch that's gone bad. But fermentation, again, increases shelf life. The production of those acids I talked about actually protect the fruit juice. And I think that the other thing you'd want to watch out for is just the fact that alcohol is produced by yeast as they ferment, and so you could end up with something that's a little bit alcoholic, and for young people, you're not going to want to consume that. But just light fermentation, like a day of fermentation, could give you tart fruit that maybe you could use in making a pie. I don't know, because again, I don't know anything about making pie, but you could definitely make sour fruit that way. I was a little all over the place, but
I liked the warning of don't make alcoholic beverages.
Right, do not make alcohol. Well, do, but under the supervision of parents, and then pitch it, don't drink it. It's interesting science, it's just not to be consumed for anyone under the age of 21.
Very true.
Period.
All right, well, we're going to take a little break, and when we come back, we have our easy as demonstration. So you'll see what that's all about in just a minute. Hi, welcome back. We're here in Sam's science lab, but we're going to take it over with math today. Hope that's okay, Sam.
I'm so happy about it.
Okay, good. Well, so it's Pie Day today, and I think one of the things that a lot of people wonder is what the heck is pie? And so that's what we're going to look at today. And I don't know, Michael, do you know what pi is and where it came from? The number pi, not.
Yeah.
You all know what pie is.
If I'm not mistaken, pi is a ratio that's designed to measure circumference, the distance of the diameter around the circumference.
Yeah, you're really, really close. It does. It has a lot to do with circles. So we've got some circular objects here in the studio, and what we're going to do, we're all going to take turns. We're going to measure. As you mentioned, it has to do with the diameter and the circumference. So we're going to measure these things, and we're going to try to figure out where this mystery number is coming from. So everybody pick an object. We've got circular objects back here. Just pick some.
Here, I'll
kind
take
of
the paint can.
I think I'm gonna take the
Paint
pie.
can? All right.
That's what I want.
You already ate pie
I
earlier.
mean,
Oh, big surprise, Becca.
I will take,
it's gonna be mine. So I've got the pie,
I'll take this little bottle thing. If you want that.
and Nate has the bottle, and then you have the hat.
Yes.
What kind of hat is that?
Kansas City
Kansas
Royals
City.
hat, buzz
Cool.
marketing for
Well, what
our
do we-
floor director.
What
Paint
do we
can.
call that? Paint can.
Paint can.
Oh, wait. Paint can.
Thank you for helping paint a brighter future for our students.
Aww.
Aww.
Okay.
It's a positive
So
paint
the
can.
two things
Yeah.
that we need to measure today are the circumference and the diameter. So we'll start with the diameter because that'll be pretty quick and easy.
Right.
So the diameter of a circle is going to be the distance. So we're going right through the center of it and the distance from side to side through the center. Is that correct?
That is correct.
Make sure I got.
Yeah, you
So
got it.
right through the center there. So that's what we're going to measure. And we're going to try to be as accurate as we can.
So we should measure not necessarily the pie, but the container with the pie in it, right?
Sure, yeah.
Yeah.
All right.
So we should measure the diameter first.
Start with this one.
Let's kind of see where we're at. It's like about 9.5 inches.
Seems
All
fair.
right. We're going to do all of these in inches today.
All right.
Okay. So next we're going to do the bottle. So Nathan,
So the bottle,
we're going to do the bottom of the bottle.
so we got almost exactly 2 inches.
2 inches. Okay. Oh my goodness. All right.
Hat.
So we got the hat.
Try to keep it as still as
Should
possible.
we do this side of the hat though?
Yeah,
yeah,
maybe
let's
from
do
the
that.
Yeah,
That
that
might-
makes more
yeah.
sense.
There we go.
So, what do we got, about 7?
Sounds about right.
Yeah, about 7.
7
inches.
inches. All right. Now let's go with the paint can.
Ooh,
Oh, gosh.
sound effect.
Thought that lid was on there tight. Okay. Boom.
All right, so we're going.
Yeah?
We got 6 and it's between 3/4 and a half. So what is that?
Yeah, what is that?
Oh, I can't see it.
6 and 5/8?
6 and 5/8.
6 and 5/8.
6 and 5/8. Wow.
Is that doable? We could say 6 and.
Well,
We could
trying-
say
trying to be as-
6.675 if we want.
Well, we're going
Six
for
point
accuracy.
6.625.
6.625. I think
Yeah, go with
that's right, is that-
6.625.
is the
Nice
That's
job.
5/8.
fraction.
That is accuracy right there. All right. Okay, so we got circumference, or sorry, my
Oh,
goodness,
wrong
what
spot.
am I doing? Let's do this.
Right, that's the diameter.
Circumference. Okay, so we got the diameter. Now we're going to measure the circumferences of these. The circumference is the distance around the whole object. So however long it is the whole way around the object, the whole way around, that's our circumference.
I always like to think of it as like, how long would it take, or how far would you have to walk around the pie if you were?
If I was
seems like
walking around pie.
visualize, yeah.
Yeah.
If this pie was gigantic in your fantasy, and you had to walk around it.
How far is it?
That is my fantasy. I just
Exactly.
want to be really tiny and desserts to be
Yeah,
huge.
just dive in, right?
Like Honey,
Yeah.
I Shrunk the Kids. That's all I want.
All right,
Work.
so circumference is a little trickier to measure. We have a tape measure that's,
Relatively
Kind of flexible.
It's not super flexible.
it'll be
All right.
difficult, but it'll be all right.
It serves its
So you want to
purpose.
hold that
I'll
side,
hold that side.
and then we'll get as accurate of a measurement as we can.
Let's move this
Oh.
bottle here.
You need a tailor's tape.
We do.
Yes, we do.
We don't have a lot of those in the math department at our school.
Yeah, help us out here. Michael, okay, so we're gonna be as accurate as we can. Are we around it?
Difficult.
Okay.
It's pretty good.
I can't really read it. It looks about
30.
30 inches.
30. Yeah, we should probably take a little bit off because we've got some. So
got
maybe
some
round
slack
down
here,
to like
so-
29 and a half
All
or
right.
so.
Yeah,
Let's
that's
do
what
it.
I was gonna.
So we're kind of like when we're doing this, just to let you know why we're rounding. When we kind of bring this around this circle, you kind of see we have a lot of these like
It's not.
little
Corners.
kinks.
Yeah.
So we're overestimating a little bit. So we want to just take a guess and think about how much we're adding.
I wonder, it'll bend more smoothly this way, right? Won't it?
Oh yeah, this is kind of
Maybe.
difficult to.
I guess that's
measure 'cause
right, it's
so
always gonna
thin.
be, yeah.
Yeah. It's mostly that
Okay.
it's just really thin, but I think you're right about.
Maybe bending it
go
the
that
other way.
way.
Yeah, we
Yeah.
can do it that way. I don't know.
So we'll go circumference of the bottle. This should be a little bit easier because again, that was like a really narrow.
Oh, there you go.
Yeah.
Boom. Yeah, just force
So
it.
this one is
Call
6.5 inches.
6.5.
6.5 inches.
Quarter.
Yeah, 6.
6.25. I think because it's right here to the bottom. I can
I'm
see
using
the metal,
the edge of it though.
but it's coming up a little bit. So if you press this down,
Okay, we'll say 6.25.
6.25.
So the bottle is 6.25 inches. Alrighty, let's go with the hat now. This is gonna be really tricky.
yeah. So we can just do it this way, and that way you have something to grab onto here,
I got you there.
and then we'll just
Bring her
try
around.
to do one of these numbers. Try not to compress the hat too much.
All right. So that comes out to about 20.
Is it compressing it over here?
Yeah, let's
a little
just
bit.
kind of round this one down a little bit too.
We need a head to put it on.
Yeah, maybe we'll do 24. What are we at?
I'd say
24.
24.
Yeah, let's make it 24. It's about 24.25, and we
Yep.
again are kind of overestimating because of the kinks in this measuring tape.
So we'll say 24.
Yeah.
Alright.
Okay.
Alright, paint can.
Paint can. And I'm looking at this paint can.
Grab it.
I don't think it was ever filled with paint. I think it was filled with popcorn.
Popcorn is even better.
You can eat popcorn, can't eat paint.
Pulling it tight for you.
We can see
why I like
our
it.
finger there.
Yeah.
We're at about 21 inches.
21 inches.
21 inches, yeah.
Alright. So now what I want to do
Throw that
is
for you.
I want to look at the ratio between the circumference and diameter. So what I want to do for all of these circles, and you all agree these are all different size circles, right?
Yes.
For every one of them, I want to see the ratio. And so I'm going to take the circumference, I'm going to divide it by the diameter for all of them. So on the first one, I took...
I can type it in as you kind of
Okay.
do the calculations.
Perfect.
and
Okay, and what do you think I should round to?
then- we can just go to the nearest thousandth, so 4 decimal places.
Okay.
Yeah.
So
Or if
three
there's
de-
only
three
three.
decimal
Three is
places?
fine.
Okay.
we
So the first one, 29.5 divided by 9.5 is 3.105.
0.05.
Okay. And then the second one is 3.125. And then the third one, the hat, is 3.429.
Okay.
And then the last one is 6.625 is 3.17.
Oh, that's pretty close. A couple of them are pretty close.
So yeah, a couple of them are pretty close.
We can do an average.
Let's do an average, okay. Let's do that.
So the reason we want to do an average is you're always going to have some numbers above, some numbers below. So some overestimation, some underestimation. So an average is a good way to kind of get a better idea.
So our average is 3.185.
Yeah.
So if we were very perfect about this, it should actually come out to that magical number, 3.1415. That it should actually come out to that number. And that's where pi is coming from, is that every circle, doesn't matter how small or large it is, this isn't really that large, but you get the idea. It doesn't matter the size of the circle, that the ratio between its circumference and the diameter, when you divide them, is always going to be pi if it's a perfect circle. Now, again, you can kind of see, and especially with that hat was really difficult to measure. So that's actually the one that's the furthest away from pi, because that was the hardest to measure. So the reason why these are not exactly pi is just because of our accuracy, but really pretty cool that every single circle does this, and that's also why pi is such a special number,
Yeah.
that every single circle does it. So we're going to look at pi a little bit more back in the studio. We'll show you some cool things that we know about it and tell you some cool facts about it. But until then, now you at least know where it come from.
All right. I mean, we're not going to have pie in the studio and not eat it.
You
Yeah,
can't
that's
not eat pie on Pi
ridiculous,
Day.
yeah.
You,
Yeah, it
you
actually-
have
I think it's a law, isn't it?
Yeah, I think that's right. I think you're obligated. If you're at home without pie, you need to go to the store.
to. Should be. All right, well, I guess we do have to answer some more of your questions. Let's actually, before we do that, let's give you our contact information in case you're joining us a little bit later. Call us with your homework questions. We're happy to answer them. Phone number's on top of your screen for most of the show, but you can also send in questions to us at Facebook and Twitter at EG Homework. You can text us at 970-680-3771, and you could email us your questions at homework@emilygriffith.edu. Ask us about pie, anything you're interested about.
Speaking of pie.
Oh,
There you
thank
go.
you. Yes, gotta have pie. All right, let's also give you our trivia question one more time. Michael, what is it?
The trivia question one more time, and don't forget to call in and win those prizes today, is what theoretical physicist was born on Pi Day? I'm very
So-
curious to see if somebody knows the answer to this question.
I know. I bet somebody does, or at least you can guess.
Yes.
This is one that you could definitely guess.
Name a theoretical physicist.
All right.
Oh, here.
I'm sure you
I
can guess
remember
it.
from my theoretical physicist playing cards.
Right,
Yeah,
right.
when I was a
Right.
I had
I'm a-
theoretical physicist flashcards.
I'm a jerk. I
didn't
just
I?
started eating it. I was
Oh,
like,
you're-
oh, pie.
yeah.
Yes. All right. So let's go back and answer some of your questions.
All right, so we're going to go back to math here. I'm thinking of a 10-digit integer whose digits are all distinct.
Pie. I'm kidding.
It happens that the numbers formed by the first n of them is divisible by n for each n from 1 to 10.
Okay.
What is my number?
I don't know, but this pie is delicious.
I know. I got so distracted
pie.
with that. I was like, oh, I got to answer a question. What am I doing? Let me see if I can find that one on here because I want the wording. What's it called?
This one is called Pi Day.
It's called Pi Day. I didn't. Pi Day
I've
fun?
got it up here too if you want to talk.
Do you have it?
Talk through it, yeah.
Oh, here it is. I found it.
All right,
Whose digits are all distinct?
correct.
All right. Man, I am slow on the draw today. It's this pie. It's the pie's fault. All right, I've got it up on my screen, copied and pasted from email. Okay, it happens that the number formed by the first n of them is divisible by n. Do you want to talk me through this, Nathan? Do you want to help me do this one?
I think this might be pretty complicated. We can kind of talk through. We might not get the solution to this, but we can talk through kind of like the process and what this problem means. So what comes to mind for me first is divisibility rules for all of these. You know, like if you want to know how many, or if a number is divisible by 3, you add the numbers together. If that's divisible by 3, then that
Right.
works.
But it's a 10-digit integer whose digits are all distinct.
Right. So that means 0 through 10, or sorry, 0 through 9.
Right,
And you
Only
can't
used
repeat
once.
any of the numbers.
right.
So,
So-
when we say the number formed by the first n of them is divisible by n, so we're saying like the first 3 numbers,
Is divisible
Should
by
be
are
divisible by
divisible by
3.
3. Oh my goodness.
the first 1 number should be divisible by 8, and the first 2 numbers should be divisible by 2. So we can actually kind of break this down. I think we might be able to figure this out.
Okay, I
Break it down and think like,
think you're right.
yeah, the first number has to be divisible by 1. Well, that's any number.
Any
So
number. So the
maybe-
first number, let's do this.
a good idea would be make a
2.
table, right? Or yeah, like what you're doing with the slots.
Okay.
So again, like kind of what we're talking about is this really is going to come down to knowing divisibility rules and trying to think that through.
So
the first one
this-
could be any number. Second one's any even number.
Right.
The third
This is like
one,
Sudoku.
yeah, it's a fun problem.
Okay.
The third number would have to be, what options do we have? We have
All 3 of these have to add up.
Right. So, yeah, all 3 of those have to be divisible. So they all have to add up to something divisible by 3. So you'd have to add up to 3, 6, or 9.
Sum of 3. This sounds like it would be a whole lot easier if it were a multiple choice question.
It would, because you could just test them out, right?
Okay.
For the 4, when we have a long digit,
It's these 2 numbers will have to be divisible by 4.
and the way to look at that is divisible by 2 twice. That's just an easier way to, like 50 if you divide by 2 is 25. That's not divisible by 2 again, so it's not divisible by 4.
Okay.
Then we got 5.
So this has to be either 5 or 0.
Right, so that's how we can start eliminating some of them, right?
Mm-hmm. Okay.
And then for 6, has to be divisible by 2 and 3.
Okay. So that means that this sum of all of these, of all of those numbers, has to be
Divisible
divisible
by 2
by,
and 3.
right.
Right.
Okay. I'm just going to say divisible by 6.
Yeah, and
'Cause
that's
that just,
easier, right?
that one's going to be rough.
7, there is no shortcut, so
Nope.
we'll just
Meh.
not think about that one for now.
Yep. Don't
8,
know.
the last 3 digits have to be divisible by 2 3 times.
Oh my goodness.
And you're right, it is like Sudoku. I think once we get a couple of them, we'll be able to like really narrow it down, right?
Yeah. Maybe.
9,
Okay.
all those digits added together have to add up to 9.
Whoop. Sum of 9. Of divisible by 9.
Yeah. And 10's easy, right? So we already know what the last number is for sure.
0.
0.
Well, yeah.
It has to be, right?
Yeah. has
Which
to be.
means
this
the
one
0,
has to be
5
5.
has to be 5.
Okay.
All right, and then you figure out the rest. while I
Okay.
try.
This is a doozy of a problem. Okay, so we already eliminated, if I go back to here, already eliminated 0. Oh, so now that has to be 2, 4, 6, 8.
So we know the second number has to be even. We know the second to last number has to be even.
I'm gonna just eat some pie here.
Yeah.
I don't know.
Honestly, this would take a lot of playing around with, and it really comes down to just testing out some numbers, like being able to eliminate, like Becca mentioned, like Sudoku, and saying like the last number has to be 0 in order for that all to be divisible by 10. The middle number has to be 5, right? That one that we pointed out.
Yeah. Oh, I wrote that in, didn't I?
Yeah.
This is 5.
So that's 5, and we could say what number, the 2 numbers before it, have to be divisible by 2 twice. So we know that has to be an even number, and so some of the numbers could be like 64 would be an option, 32 would be an option.
There are so many options, though.
Right. So again, this we could probably spend like 10 minutes on this, but
I'm sorry if your teacher assigned this homework problem
Yeah.
because it's not easy.
think about the divisibility rules and just play around with it. You'll start to be able to eliminate some of the options.
Very true. And this is probably one that you would play with. This is not something you can write an equation for.
Right.
Not at all.
Yeah.
It is a lot like Sudoku. So
Yeah.
I don't know. We'll play around with it more, see if we can come up with an answer by the end of the show. But who knows?
Yeah.
But at least we gave you an idea of what the question means.
Yeah. A way to start.
Yeah.
Yeah.
So hopefully we were kind of helpful.
Yeah.
All right. Well, let's go get more of your questions answered, Michael.
While you guys are trying to figure that one out, Sam, I got a nice little easy science question
Okay,
for you.
perfect.
How are chicken wings different than human arms? And then they actually gave the options. Chickens have more phalanges, or fingers. Human joints bend more easily. Chickens have more wrist bones. Or chickens have fused phalanges.
Yeah, it's a great question. So I think let's just start by talking about what phalanges are. If we could jump to my screen, I'm just going to show really quickly. This is a simple diagram of a human hand, and it kind of shows you the breakup between the carpals and the phalanges. So we've got your carpals and your metacarpals, which essentially make up the larger part of your hand, your palm, and the bones inside of your palm. And then the phalanges are the finger bones. And you've got your proximal phalanges, which are the bones that are closest to your hand, the intermediate phalanges, which are in the middle, and the distal phalanges, which are the most distant. But that doesn't really matter too much for this problem. We're really just thinking about the fact that, okay, the phalanges are the fingers, and then just noticing where the carpals and the metacarpals are. So here's a generalized bird arm. We're going to just operate from the assumption that chicken arms are really similar to bird arms in general. And you'll notice, and actually what I need to do here, I need to get us a picture of, let's see, a human arm bones entirely, because I meant to show you that in its entirety, so hold on one second. Okay, if we could jump back to my screen. So the bones in the hand aside, you can see that we've got the humerus bone, which is the upper arm bone, and then the lower arm is comprised of two bones, the ulna and the radius. And if we look at our bird, oh gosh, what did I do with it? With our bird arm, we can see that the bird arm actually has the same parts. So here's the humerus in the bird arm. It comprises the upper arm. And, oh gosh, there's the humerus in our human arm. So we can see that those are really similar. And then you've got the ulna and the radius, the lower arm in the bird. And you've got the ulna and the radius, the lower arm in the human, right? So things like this, right? I'm just going to point out right now, things like this are reasons why scientists started to believe, going back hundreds and hundreds of years, but we're more convinced in recent years, that there was a connection between all different forms of life, right? Like, if chickens and humans weren't related through evolution, why is it that we continue to see so many of the same structures? And obviously not just chickens and humans, but if you look at any two forms of life, you can often find similarities between them. And so it begs that question, okay, if they're so similar internally, the structure, does that say something about where they came from? And maybe how they're related. So we can see in the answer to the question, just to get back to that, you can see that up here the metacarpals, in addition to the phalanges of the bird arm, are fused. And so the correct answer is going to be D, chickens have fused phalanges. It's not true that chickens have more wrist bones, right? There's not extra bones hiding in the wrist. There is the allula, but I don't think that they were counting that. Human joints bend more easily. That may actually be true. I don't know too much about bendability in chicken joints, but that was not the answer they were going for here, I'm convinced. And then chickens have more phalanges. You can see that actually chickens in theory have the same number of phalanges, but they're all fused together again. So you can sort of see that in this image. And then just really briefly, I just wanted to show, I've got it somewhere. This is kind of a cool image which shows the distinction between a human arm, the bones in a human arm, the bones in a bird arm, and the bones in a bat arm. And the thing that is so noticeable here, each bone is color coded, so you can see like the red bone is the ulna in all three, and you can see the upper arms of these three creatures are very similar, but then when we get to the hands of the three creatures, the bird being all fused together here is so different than the human down here. But if we look at the bat arm, or the bat hand, excuse me, you can see the phalanges of the bat hand are much more like a human hand. Of course, the phalanges are much longer, and we could maybe even see the carpals are more compressed, but even so, and this is one of the pieces of evidence that bats are more closely related to humans than birds are. There are other pieces of evidence, right? The fact that that bats exhibit all characteristics of mammals, like they have warm blood, give live birth, all those kinds of things. Those are other pieces of evidence, but looking at the morphology, the shape of an organism's bones, can really help us to sort of see these connections. And so the question was great, but I think sort of the thing behind it, this idea that by studying bone structures from one organism to another, you can see these connections that suggest that all life is connected and related somehow. How's it going over there, math geeks?
Pretty good.
Yeah, we're researching.
So just to kind of show you really quick, if you look at my screen, the process I was doing really quick, you really have to just test out a bunch of numbers and eliminate. The solution that we found is really through a computer program, where they run an algorithm. So the computer program is just doing this over and over again.
Just testing numbers over and over again to see if it actually works.
So it was 1, 2, 3, 4, 5, 6, 7.
It's not 1, 2, 3, 4.
Okay.
No.
I tested
awesome.
that just to see, because
3,
I
8, 1
thought
is something.
5 is in an interesting spot and 0 is in an interesting
Right.
spot. 3 was in the wrong spot, yeah,
Okay.
exactly.
Wrong, yeah.
I thought the same thing. But okay, well, let's get our trivia question answered.
All right. So, what theoretical physicist was born on Pi Day? Albert Einstein.
Oh, that would
Einstein.
have
Yeah.
been my only guess.
That would have been my only guess
That would have
as
been my only
well.
guess.
How many
too,
theoretical
so.
physicists do you know?
In the Star Trek episode Wolf in the Fold, Spock spoils the evil computer by commanding it to compute the last digit of pi's value. And also, the Greek letter pi is the 16th letter in the alphabet, and P is the 16th letter in the Arabic alphabet as well.
Latin
interesting.
Or Latin alphabet,
Great.
thank you.
Not a coincidence.
No,
I
not at
have
all.
a good one.
William Shanks calculated the first 707 digits by hand, but he made a mistake after the 527th place.
Oh, what a bummer.
Uh-oh.
Yeah, that would be frustrating. If you ever try to solve a math problem and you're like, I made a mistake on the second step, I got to start over. Imagine if You made a mistake on the 527th step.
That would
and
make me
didn't realize
cry.
it for a while.
That would make me cry. Well, I have a very interesting one. It's not all that academic, but it's still kind of cool. If you look at my screen real quick, pi backwards is pi.
Coincidence?
I think not.
Definitely.
Yeah. Very cool one. I don't know. I think
Yeah.
that one's pretty cool. But
That is.
Nate, I did look it up, and I don't know if this is true, but the claim is that if you take the diameter of a foot of an elephant and you multiply it 2 pi times the diameter of a foot of an elephant, it's supposed to give you the height of that elephant.
Oh, wow.
Interesting.
Now, I don't know if that's just garbage, but there was a guy who wrote a book called The Joy of Pi, and he claimed that was true.
Interesting.
Wow.
very cool. Well, this is going to be a quick goodbye, but we will see you again tomorrow. Remember, 4:30 to 5:30. Send your questions in. Thank you guys for joining us for Pi Day. Happy Pi Day.